right, so welcome kids. My next recording for you, I'm going to run through some things that I ran through in class so that you can hear it now on this tape or this recording. That's how old I am. So this was the ionic bonding interactive, and this is, you should be able to do this yourself without me talking, but just to recall, when you have two similar charges, in this case both negative, they repel each other. And there is no desire for them to be together. And I joked in class that this is much like me chasing my daughter to try to get a kiss out of her. This is the opposite of that. This is a mutual attraction. When opposites attract here, the plus and the minus come together. They are attracted to each other, and to pull one away from the other takes some doing. And otherwise, they kind of stick together. All right. So this is what happens with ionic bonding. These metals on this side of the periodic table will form positive ions. These non-metals will form negative ions. And if we look at NaCl, when they react to form a bond, sodium will lose that electron and it'll go to chlorine. That makes the sodium ion positive and smaller because there's more protons than electrons pulling them in tighter, and the chloride ion bigger. Now there are too many electrons for the protons to handle, so it gets a little bigger. And now those are attracted to each other because, as we said, there's a positive and a minus. And in the real world, chlorine acts as a binary molecule. There's two chlorines together as Cl2. So this is how it would look like in real life, that the chlorines would get electrons from the sodiums, get bigger, the sodiums get smaller. Now we have these two negatively charged chloride ions next to each other. They don't want to be next to each other, so they sort of readjust so that the positives are surrounded by negatives and the negatives are surrounded by positives. And then others join the group, and we have what's the start of a lattice. And as you can see there, there's a chloride for every sodium. All right, so I am going to kind of get out of that right now and do the covalent real quick. You can do the rest if you want, as I said, but those are the main points. Covalent bonding starts, here's two hydrogen atoms. That's the nucleus with a proton and this electron flying around. And as you can see, this electron flies around at all ends of the atom. But as you get them closer together, something happens where they kind of stick together right there. And if I now try to pull this away, it can't get pulled away. There's an attraction that stays together, and I can drag that one all over the place like that. But you'll notice that the path of these electrons now stay between the nuclei. They're staying on this side of things. Whereas before, if I yank it really hard like that to get them apart, the electron will sometimes go on all ends of the nucleus. So part of this bonding phenomenon is that the electrons sort of stay in between the two nuclei that they're sharing. So let's look at this here. This attraction of the nucleus to the electron is represented by this purplish pinkish line. And this one, let's get that moving. When it gets closer, you can see this nucleus, besides attracting its own electron, sometimes will attract this other electron when it gets close. And that attraction is what causes the covalent bond to form. Now this nucleus is attracted to both electrons, as is this nucleus, which will be, so there they are. They're what we say sharing, but in this case they want to make that it's a fighting over the electrons. They're both attracting the electrons, which is how this happens. That forms a bond. So these bonds tend to form here in the non-metal area of things. They have electronegativity similar to each other, so when they bond with each other, that is what happens. And oh yeah, don't forget hydrogen is a non-metal, even though it's on this alkali metal area. It really is a non-metal rather, and should be over here. And so and then this got into a little more. But as you can see, this bond length, there's a energy benefit to getting closer together, but then they can actually get too close. And at this point, the nuclei repel each other, and that's why they push away. But there is a sort of sweet spot, and that is called the bond length. And that's about all that happens there. Again, you can read through this on your own pace if you want. So getting back to now, let's get into the PowerPoint. So from the beginning. So chemical bonds are on a spectrum, and on one side of the spectrum you have ionic, which there's a total takeover of an electron. On the other side of the spectrum you have complete covalent sharing, and in between there's shades of this sharing and takeover. Here is just a brief review. Atomic radius we talked about is relative size of an atom. Ionic radius, relative size of an ion. Ionization energy, the amount of energy required to remove an electron, and electronegativity to attract an electron from other atoms. Most of this chapter unit will deal with electronegativity because we're bonding, so we're attracting electrons from other atoms. So based on their size and position, metals tend to have low attraction to atoms and lose electrons easy. They lose electrons, they become positively charged, and they become cations, and nonmetals have high attraction to electrons, so they gain electrons easy. Gain electrons means they have a negative charge in an anion. So why do elements bond with each other? They want to be like the noble gases. So they want to have full electron outer shells. That's usually meaning 8. That's a stable thing. So that's why they try to get to that stability and obtain 8 electrons. So in order to obtain this, they will either lose electrons like the metals do. They lose a couple electrons to become cations. They'll gain electrons like the nonmetals do, or they're going to share electrons. That's how they're going to accomplish this bonding. So remember, valence electrons are these outermost electrons here. Those are the electrons that another atom, as it's coming in, will experience first. So those are the electrons that sort of dictate reactivity. All right, so determining which kind of compound will form. As you already know, when metals and nonmetals get together, it's ionic, and that's due to electrons being lost and gained. When they're sharing, then it'll be called a covalent bond. And the difference in electronegativity can help you determine which of these will occur. So if there's a large difference, it'll be ionic, and if there's a small difference, it'll be covalent. The metal-nonmetal thing still works though. But here are the electronegativities. As you can see, the metals have very low numbers for the most part, especially around here towards cesium. The nonmetals have very high numbers. So when these get together, the difference in this electronegativity is large, and that would be an ionic situation. When these nonmetals get together, like if oxygen were to bond with, say, hydrogen, the difference there is 1.4, not near as drastic as like oxygen with potassium or chlorine with sodium or any of those. It's not, those are much larger numbers when you subtract the difference. So when these nonmetals get together, they will form covalent and different spectrum of covalent bonds where they're sharing equally or not equally. So ionic is like this, where there's an absolute taking over of electrons. Like these kids are not sharing well at all. This kid took all the little rings there, and this one is left with much smaller things, and that's what happens with sodium. Sodium gives its electron over to chlorine. Now sodium thinks it is like a noble gas with its configuration, and chlorine feels like it's a noble gas with its configuration. Covalent bonding is sharing, and in this case the hydrogen shares its electron here, notated with a blue cross. This is the hydrogen electron, and the oxygen electrons are the red, and they share them. And in that case, hydrogen thinks it has 2 electrons like helium. This hydrogen thinks it has 2 electrons like helium, and this oxygen thinks it has 8 electrons like neon in that case. All right, and the sharing can depend. You can have a polar bond where they're not sharing equally. One atom has the electrons more than the other. And again, we'll see that with electronegativity. Nonpolar is when atoms pull and share nicely. That usually happens between 2 like atoms, like hydrogen or chlorine with each other. You know, hydrogen with a hydrogen or chlorine with a chlorine. Then you're going to have this nonpolar bond form because neither one is going to pull the electrons any more than the other. I am going to stop here and start another one after this.